Hi, we're going to talk about math some more, multiplication. So this is chapter 20, lesson 5, pages 403, 404, and today's lesson is about problem solving. So it's all word problems. It'll be really good. You'll like it. So this is the page 403. Oh, hit it one more time. So 403 and 404, and what they've done here is they've said we're going to go on a field trip in California because our textbook is published for California. And it says California field trip at the Mining and Mineral Museum. You can learn about gold mining in California. Yeah, exactly. As you walk through an old mine tunnel, you can learn about the California Gold Rush. Hey, you studied that a lot in 4th grade, too. You can also see many kinds of rocks. Rocks are a lot of fun. Choose a way to solve. Show your work. At the museum, Bessie sees 5 display cases. Each case has gold nuggets. How many gold nuggets does Bessie see? Well, one of the things I want to try to do when I'm doing a multiplication problem is I'm going to, first of all, I'm going to circle the numbers in my word problem. And then I want to think about arrays, because especially when I looked at the test that you're going to be taking, an array is really helpful, and I'll explain why. So there's 5 display cases, and each case has 3 gold nuggets. So it's kind of like when we make an array. You remember those boxes. The number 5 comes first. So 5 is going to be the row. So the display case is really big. 2, 3, 4, 5. But those gold nuggets are pretty large too. So I basically have 5 equal groups. That is super important. 5 equal groups. And in each equal group, there are 3 gold nuggets. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So I'm going to say 5 times 3. 5 equal groups of 3. I wrote that wrong, huh? Sorry.
Good.
So the equal groups is right here. I'm still confusing myself.
It says
5
Bessie sees 5 display cases. So it'd be almost like you
sets.
put 3 circles, or 5 circles and 3 in each circle. You could do it that way too as a picture.
Okay. But my picture isn't so bad. I just need to understand
5 times
that there's
3.
5 sets of 3.
Yep.
So the equal groups of 3. This is what was difficult. When I was talking to someone about it yesterday, equal groups is the second number. So 5 sets of 3. So I'm going to do skip counting by 3s. 3, 6, 9, 12, 15. Now we also know, of course, because we've talked about it earlier this week, that 3 sets of 5 would still end up being the same answer. So it's going to be 15 either way. But the equal groups, each display case is 3 gold nuggets. So those are the equal groups. Okay, so that's the first one. If you'd like to pause the video, you can. 3, 2, 1, pause. We're back. And so if you wanted to keep the video going, that's okay too. But I'm going to walk you through this one right here and the next one. And then it has, this lesson has 4 more problems on the back page. So Teresa sees 4 display cases. Each case has 10 pieces of silver. So how many pieces of silver does Teresa see? So keeping my same model, this is going to be 4 equal groups, but in each equal group, there's 10 gold nuggets. I'm not going to draw all the gold nuggets. I just know that we're going to be skip counting by 10. So there are 4 display cases now, and this problem is no longer here. There's 4 display cases, and each equal group is 10. And I love skip counting by 10 because we know the second number is 0, because there's 0 in the ones place. So 4 times 10 is 40. So the answer to the second one is 40. The answer to the first one is 15. And now we're on problem number 3.
Ms. East, in
Yes.
the show box, does it matter if they show a picture or just the times table?
Oh, over here?
Mm-hmm.
You know what the nice thing about these word problems is? That you can do either one, whichever one you like. And, you know, everybody's different, just like everybody looks different. Some people have long hair, some people have short hair. Everybody's different. Everybody thinks a little differently. So basically, whatever works for you, fine. One of the things you don't want to do, though, don't leave this blank. This is like your thinking area. So you definitely want to have something there, because you don't want to just watch the video and copy down what I write down. Because if you do that, you're not really learning. So having that experience of thinking, and keep in mind, you can pause the video anytime you like. You can go back and look at the beginning of the video. You can do whatever you would like because you're watching a video. That's a nice thing. Okay, good question, by the way. Okay, so now this bottom one is a little bit more complicated. It says 6 first graders and 7 second graders visit the museum. Each student buys 2 mineral samples at the museum store. How many mineral samples do the students buy in all? Now, there's a couple of different ways to do that, probably even more than just 2. But one of the things that you can do in this one, the nice thing is your equal group is just 2. So the equal group of 2 is not too bad. You could say, okay, 6 first graders, 7 second graders. So what I need to do, let me circle those numbers first, 6 and 7, and then this number is my equal groups. I'm going to put EG for equal groups. So I can say, okay, 6 plus 7 is 13. And then I could say, okay, those 2 numbers together makes 13. So then I have 13, and my equal groups is 2. So then I could say, okay, 13 times 2. Now here's the thing. That's a little bit of a hard multiplication problem. So I'm going to show you a different way to do it, and what we'll do is we'll solve it both ways, which is kind of fun. So over here, what I'm going to say is 6 first graders times 2. And then I'm going to say 7 second graders times 2. So these are 2 not very difficult multiplication problems. 6 times 2, that's just a double. If you buy a dozen eggs, 6 times 2, 12. And then 7 times 2 is just one set of 2 more. So I can do that in my head. 12 plus 2 is 14. But that's obviously not my answer, because it says, as Mrs. Lopez reminded me yesterday, in all. So that means I need to get all of the kids involved in this answer. So I have to add these 2 together. 2 plus 4 is 6. 1 plus 1 is 2. So my final answer is really 26. So I'm going to write that here. Now let's see if we can get the same thing when we work this way. What we could do is we could do skip counting by 2s 13 times.
Could you also say 13 plus 13?
You could. Whoa. Because we know that in multiplication, order doesn't matter, right? So 13 times 2 is going to give us the same product as 2 times 13. It's very important. So yeah, Mrs. Lopez, that's a really good idea. I'm going to even just do this and kind of move this up a little bit. 13 plus 13, definitely 26. Great. And now, if I can get all my fingers ready, skip counting by twos.
Go ahead.
2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So 13 sets of 2 is definitely 26. Thank you. I thought I was going to have to take off my shoes. So any way you do it, you're still going to get the same product. So that's really important, and that's one of the things you have to know. And no matter what you do here, it's really going to be a 2-step process of doing this. So now we're going to go to the next slide. Thank you, Mrs. Lopez, very much. And this is what your page looks like on the back side. Now you've done 3 of them. We did 3 of them together. Mm-hmm. So if you want to pause the video and try these on your own, and then turn it back on, 3, 2, 1, pause. And now you're back. If you want to do that, then that's fine. And see if you get the same answers that I get. And then you can grade your own paper. You can mark it. Okay, here we go. Jason sees 6 miner's pails. Each pail has 2 hammers. I think I have my equal groups there. How many hammers does Jason have in all? So I have 6. Equal groups is 2. So I'm going to do this math problem. 6 times 2. Hey, I think it's that dozen eggs one again. It is 12 hammers. Okay, so not too bad. 20 people have a ticket for the first tour. 35 people have a ticket for the second tour. 17 people have a ticket for the last tour. How many people have tickets for a tour? I don't even think that's a multiplication problem.
No, I think
unless
it's all adding.
you could say 20 times 1 and 35 times 1 and 17 times 1. But we know our times 1 tables pretty well. So I think, yes, Mrs. Lopez, I'm just going to do some adding. 20 plus 35. So in a way, this problem is really review. And I think I'm going to have to do some regrouping here. So 5 plus 7 is 12. I know I can only write 1 digit per column. So I'm going to go up here and I'm going to write a 1 up above. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 1 is 7. So my answer is 72 people. So that's not so bad. Okay, Ms. Brown wants to buy some postcards. Each postcard costs 50 cents. How much do 5 postcards cost? Really, this is a multiplication problem. Because you can say there are 5 postcards and each one costs 50 cents. Now, what's interesting is you have a basic fact there, but it's a multiplication fact. The basic fact is 5 times 5. So we're going to skip count by 5. 5, 10, 15, 20, 25.
Then just add a 0.
Exactly. But here's the thing. So it's 250 pennies. But I know, I'm going to make room for this here. I know that 250 pennies is really $2.50. So that's a little bit of a hard problem. The other thing you could do is you could skip count by 50. 50, 100, 50, 250. So 250 pennies is $2.50. So then I'm going to put that answer right here. We usually don't write 250 pennies. You can if you want. It's not going to be wrong. But usually we make 250 into dollars and cents. Okay, Jana has 3 quarters, 2 dimes, and 2 nickels. She buys 2 postcards. Well, we have to remember that postcards are 50 cents. How much money does Jana have left? Hey, this is another review problem. Back from our money. Yeah. So what I'm going to do is I'm going to write down what each one of these is. And technically, that's really multiplication. Jana has 3 quarters. I happen to know that 3 times 25 is 75. And then 2 dimes, 2 times 10 is 20. And 2 nickels, 2 times 5 is 10. And then it's a 2-part problem again because I'm going to have to add up how much money she has all together. So 75 plus 20 plus 10. So I'm going to add up how much she has all together, and then to figure out how much change she has left over from her purchase, I need to subtract. So I don't have to regroup here. 5 plus 0 is 5. 7 plus 2 is 9, plus 1 is 10. So she has 105 pennies, or $1.05. So I'm going to take that $1.05 and I'm going to subtract the cost of 2 postcards, 50, 100, or $1. It doesn't look like a super hard math problem right there. 5 take away 0 is 5. 0 take away 0 is 0. 1 take away 1 is 0 again. And when you are subtracting, we know with decimals, the decimal just comes straight down. So my decimal goes right there. There's my dollar sign. I know it got kind of squished in there, but I hope you can see it real well. Because the answer is, it could be written one of 2 ways. $0.05 or
5 cents.
When we have that, just a small amount of pennies, the easiest way of doing it is like that. So 5 cents is what's left. Okay, 1 second, I have to erase. And all our good answers are gone, but if you didn't get all of those, like I said, you could just make the video play back a little bit, and then you could check the answers and check for your right answers. Okay, it says, sorry. Do you mind going back? Yeah. So this is just some basic advice. Whenever you do word problems, always remember to go slow. Sometimes you have to read it twice. Don't go super quick because you're going to leave out a detail. Like Mrs. Lopez said yesterday about circling the numbers. That's really important. So go slow. Be logical. Okay, so if she's buying postcards and your answer ended up being she gets $100 back in change, you did something wrong, okay? Because nobody's going to get $100 back after they buy 2 postcards. So be logical. And then write things down that could help you. The other thing you notice too is not all of these are multiplication problems. Some have a little multiplication, but it's also reviewing addition and subtraction. So that's all good. Okay, now we can go next. So the last part of the lesson for today is you can either practice multiplication facts with your flashcards, or you can practice by using Gigi for 20 minutes.
I don't know. I think they should practice multiplication cards too for maybe 5 minutes.
I was thinking both.
Yeah, both of them.
Couldn't Hoyt?
Yep.
Or play a game where it's doing multiplication. Okay, so that's all the fun you're going to have when you're doing that. Yay. Okay, so we have some more arrays. This is so cool. Go ahead. So this is Zoe's array. I love how she did potatoes. So she has 2 groups of 5, which makes 10. And she wrote the flip side of that. She said 5 times 2 is 10, which is fine because the product is the same either way. And you know what? We were talking about that word product. You know, here's the thing. If you have words in math, some words are like down here in importance, not so much. Some words are like medium. For example, sum. Sum is important. Difference is important, right? Product is up here. You really need to know what the product is, especially for next year in 3rd grade and 4th grade and 5th grade, because you're going to be using that word a lot. So you really want to try to remember that word because it's a brand new word. You've been hearing about sum since 1st grade. Isn't that right?
Difference. Gotta know about difference.
Oh,
too, though.
difference. Difference is important too. Yes. Okay, next one. This is Nadia Miller. She also sent us an array. And so she has rocks. And she wrote her array right here. She has 3 groups with, 3 rows with 3 equal parts. So 3 times 3 equals 9. Great job. I think, yeah, it says Nadia's array. Good job, Nadia. Thanks. And then here we go, final array from our friends. And this is from Jackson. He wrote his name right here in cursive. Very nice, Jackson.
Jackson likes cursive.
That's a good thing. And he wrote that J perfectly, which is excellent. So what Jackson has, we actually call these squares. And you know, they kind of look like a square. Especially this one right here, because it's 2 sets of 2. So 2 times 2 is 4. This one is 3 sets of 3. 3 times 3 is 9. And this one, are those bumblebees?
Looks like it. Or
Those are really
butterflies.
cool. Either one.
But I think it's bumblebees because it has the stripes, maybe.
And the stinger.
Mm-hmm.
So this is 4 sets of 4. So I'm going to write that one down. 4 times 4 is 16. So, very good. Oh, I think we have a fun little guy right here. So that guy is jumping for joy because of all these squares. So thank you, Jackson. Thank you, everyone who sent in an array. Those were excellent. Good job following instructions. So I'm going to say ta-ta for now.